welcome back to the vlogs.
Sorry.
Okay, so here's the deal. With circles, we're going to have a ton of theorems introduced as well. Okay, a ton of theorems. Here's this circle. No, it says 8 sides. Is that what you're trying to read? So here's the page that talks about circles. You can keep this and you can fill it out as we go throughout this chapter. You can color code it if you want, because there's different aspects to circles: tangents, radiuses, diameters, secants, chords, arcs. Let's pass one, please. Okay, so there's lots of things that we do with circles. Did I give you two at your table, Faith? Oh, okay. Give one to whoever's. Because he gives everything. Okay. Now, with circles, there is something called a tangent. Now, we talked about tangents last unit, right? With tangent, sine, cosine, and tangent. This is something different. This is a term for circles. Okay, so I'm not using the tangent button on my calculator. Do you understand what I'm saying? Okay, so tangent, endpoint theorem. If two tangent segments share a common endpoint, then they are congruent. So here's the deal. This segment right here, EA, and this segment right here, EB, are tangent to that circle. This is what classifies it being tangent. And I think tangent is on your paper here, okay? So it's a line segment, okay, where it touches a circle once. It's going to touch the circle at one point, okay? A line segment that has one end point, it just touches the line only one point. So a line segment touches only one point on the circumference. That's this box right here, the middle of the middle. So it's a line segment that touches only one point on the circumference. So this is my circle, right? The circumference is any point that's on the outside of this circle. So if something is tangent to a circle, it touches the circumference one time. Touches that circle one time. On your paper, do you see how the tangent kind of continues like this? It's not exactly making like a triangle there, okay? So a tangent just means that it touches my circumference once. Okay, something that is tangent to a circle touches the circumference of a circle once. So if AE, segment AE, and segment BE are both tangent to a circle, then that means that segment AE is congruent to BE. So this segment here and this segment are congruent. Do you see what I'm starting to create? I'm starting to create an isosceles triangle.
I love that.
Okay, so this is why we need to know all about triangles before we get to circles. Carly's like, oh good. Okay, tangent and radius theorem, okay? A line is tangent to a circle in the same plane if and only if the line intersects the circle once and is perpendicular to the radius of a circle at the point of intersection. You know what a radius is of a circle, right? What is it? Yeah, it's half of the diameter. Radius is half of my diameter, okay? So on your thing, I don't know which one it is on here, can't remember. A portion, let's hear. We'll have to figure that out in a minute, because I want. Yeah, a line segment that passes, well, that might be a different one. Okay, so a tangent to a circle C, A is tangent to circle C in the same plane if and only if A is perpendicular to the radius. So here, right, this is my line that's tangent. It hits that circle one place. It hits this circle in one place here. Okay? And right here it shows me that it's also perpendicular with that radius. So if it's perpendicular to that radius, now I've caused some things and I can start to figure out some angle stuff. And I can create things like this. Okay? And then I can use sine, cosine, and tangent to start to solve for things. This is why we're looking into all these. So if a line that is tangent to a circle, and tangent means that it hits the circle on the circumference one time. If a line that is tangent to a circle intersects with the radius to make a perpendicular bisector, then that means that I have the tangent and radius theorem happening. Okay. Circles, segments, and lines. Okay? A segment with endpoints on a circle. Okay? Segment with endpoints on a circle. A chord is a segment with its endpoints on a circle. If it passes through the circle's center, it's a diameter. So this right here is my diameter because it passes through the circle's center. But this right here is a chord because the endpoints are just on the circle. Okay? So on your,
Is it the top middle?
yes, a line segment that has both endpoints on the circumference is the top middle. That is your chord. And then a line segment that passes through the center and has the endpoints on the circumference is the diameter, the top, the first one. Okay? Top first is diameter, top middle is chord. And you can take this, if you notice, it gives you like little things to do. Label a sector, label a segment. It gives you like little checklists. It's kind of like a coloring activity for circles so that you can maybe, if you learn that way, help you out a little more. Okay? You know what a diameter is, you know what a radius is. Chord, I think you should know what that is. You probably have gone over that in the past. It's just, touches both endpoints are on the circle someplace, and it does not pass through the center. Okay. Secant, it intersects a circle twice. So secant is going to continue through the circle. Okay? A secant is a line that goes through the circle. It intersects it at two different points, and it's continuing on. Okay?
Which one is this?
The bottom.
No, like which definition is this?
I'm checking. A line that intersects the circumference at 2 points. Yep,
It's the bottom.
bottom right.
What's it called? Secant?
A secant. A secant.
About spelling it out.
Okay. So secant is going to pass through the circumference twice. And then once again, we have tangent on here again. Tangent intersects the circle once and is in the circle's plane. So it intersects the circle once. Okay, we talked about that one already. So, like I said, we get to start to make triangles off of circles.
That's like
I
weird to
hate
think about.
this.
Circles and triangles.
Yeah, because you can inscribe any shape into a circle, right? Because I have a 360-degree around that shape. Or I can inscribe a circle into a triangle. Because if I have a triangle, I can put a circle in the center of it. So I can start to work this. Okay? So here it says finding a circle's radius from a tangent. Okay. So I need you to think, because I already gave you rules to solve this, so let's talk this out. I want to find a circle's radius from a tangent. Here is a line, AB, that is tangent to that circle, correct? Okay? And then I have this. So AB is labeled as 9. A to this segment here is labeled 6. This is R, and this is R. Okay? If you have a line that is tangent to a circle and intersects at the radius, what type of angle do I have? So this line here is tangent to the circle, yes?
Yeah.
And it intersects at its radius.
A right angle.
So I have a right angle. What do I know about triangles with right angles? How can I solve for missing sides of those?
A squared plus B squared
equals
equals
C squared. Diagram theorem. A squared plus B squared equals C squared. Now, what's my C squared? What's this part, right? The AC?
Yeah.
It's not 6, it's 6 what?
Well.
No. Not 6R, I'm not multiplying them together, I'm doing what with them?
No, I was gonna say
6
12.
plus R. I'm 6 plus R. So my C is 6 plus R. But I have to do what with that? Square it.
squared, that's.
So this is gonna involve using distributive property or using foiling, okay? Does this take time? Yes. Is it hard?
Yes.
What is my a squared? What is your a squared? Your a is always your shortest side.
Nine.
R. So I put r squared in there. And what is my b squared?
9.
Nine.
Okay, so now I have an equation that looks like this. R squared plus 9 squared equals 6 plus r in parentheses squared, correct?
Yeah.
Okay, I'm gonna leave r squared like it is because I can't do anything. What's 9 squared?
81.
Good, and then over here I have this, 6 plus r times 6 plus r.
36
So I
times
have
four.
to,
First,
Boil
outer,
it.
inner, last.
okay, so
Boil
6
that
times
blood.
6 is
36.
36.
6 times r,
6R.
6, or r times 6,
6
6R.
and r times r.
R squared.
Okay,
36.
so I get, I'm sorry, I was erasing because I needed to put a plus in there. So I get this, right? Now what do you think I need to do?
Subtract
like
Now you
R
gotta,
squared.
Combine like terms.
Combine like terms, get everything on one side, all that fun stuff.
Yeah.
Okay?
Is it really fun though?
I do, I like algebra.
Thank you.
Personally, I think algebra's fun. Okay, so I have r squared, I have 81, I have 36, I have how much here?
6R squared.
How about?
Boom.
And then you can minus 36 from 81, and then
Okay, so-
minus r squared from the side.
So what is 81 minus 36?
A number that I don't know.
No, never mind. I was gonna try to do it.
45? Okay, so I have r squared plus 45 equals 12r plus r squared
And then
And
minus
then
r squared.
minus the r squared so that they cancel. And I get 45 equals 12r. Now what am I doing?
Divide by 12.
What's 45 divided by 12?
3.75.
What is it?
3.75.
3 3/4?
Yes.
Okay, 3.75. Now, that's what my r is. What was I trying to figure out?
What the tangent.
Finding a circle's radius from a tangent. Did I figure out what the radius is?
Yes.
Yes, I did. It was 3.75. And it is centimeters. Okay?
Yay.
That's nothing new. Like, in the aspect of the math portion, that's nothing new. In the aspect of I need to know what these terms mean so that I can set up Pythagorean theorem so that I know it's a right triangle, that's what you have to recognize. If something is tangent to a circle and it meets at the radius, intersected by the radius, it creates a 90-degree angle. What, Priya?
Oh, no, I was just making a 90
Making a 90 degree. Okay?
It's not up. Yeah, there you go.
What is the approximate
Watch out, Dylan.
distance to the horizon? What's horizon?
This.
Yes, good. This. From the summit
Yo,
of,
yo,
I can't read because it's in the,
That's by 3.
from the summit of the
Because you guys
Everest.
left.
The Earth's radius is about 6,400 kilometers, and the Everest is approximately 8,000 meters high. Everest is the highest of the 8,000 meter peaks, so we will approximate its height at 8 kilometers above the Earth's surface. How do you think I can solve that?
I don't know.
Oh, you're up on there. No.
We're on you for no reason.
Draw it out.
It's just like we don't like her.
What do you think that's going to create? It says that the Earth's radius is about how much?
I don't know. I can't see that.
6,400.
Okay, so the radius, 6,400 kilometers. Everest is approximately 8,000 meters what? High. High.
Hard.
Height. Okay, the height. So if I know that the radius, so here's a height, radius, right? Because if I have a circle, the height is probably tangent to that
Like I
radius,
said, draw it out.
right?
Good job, babe.
Wow, you're so cool.
Okay, and then it says approximates the Earth's surface, okay, something like that.
Why would we have to do this in life?
So look,
Let me do this so we have a
they
message
drew it
right.
for you, a circle. Oh, why did I just, okay, here's my circle. Once again, my line is tangent to that circle. What?
Is this gonna, is this- Okay, is this chapter, like, section gonna create 90-degree angles, or is it gonna be like different angles? Just for this, like, first one.
This section will create 90-degree angles.
Black.
So we'll just, okay.
Later, we're gonna get into like putting pentagons and different shapes in there.
Dude,
But like,
are you
why?
kidding?
Triangles are perfectly fine.
Oh, you
Yeah.
can create a triangle out of a pentagon.
Yeah,
But
we
like,
know,
no,
but why?
no, circles.
In a circle.
No, but no.
Dang.
Then why can't we just?
Those are cool pictures.
Okay, so Earth's horizon, you said goes this way, right? Okay. And it said that this is 6,400, this is 6,400, and they said that the height of Everest is 8. Okay? So they drew a diagram that way. How can I solve for the Earth's horizon? How can you solve for the Earth's horizon from there? How can you solve for the Earth's horizon from there? You know that you have to do what? Guys, focus. Shut your mouth and focus. You know you have to do what? Use a Pythagorean theorem. So what's your,
Our C squared is 6,406.
okay, you say that, okay,
6,400.
you say that C squared is 64,000, right?
But it can't.
Plus
Here's the
8.
problem,
Yeah,
it's
it
right
can't
here,
It has to be the 8 part.
plus,
Six,
That's
what I just said that.
400 and
so it's 6,400, right? Plus 8 squared equals what? What's my
B squared.
B
Six,
squared?
four,
6,400 squared, okay, 6,400 squared,
And S squared.
and then, yeah, and then ES squared technically, because it's this. So 6,400 squared plus ES squared, right?
Wait, what ES?
Because that's the name of this segment, ES.
Oh, the E. Why the E's all the way down there though?
The E goes with this point.
Are you
The
kidding?
point to the
I'm not
pair.
kidding. Because they're not gonna draw it up there when it's something that's tangent to, they're just gonna put it there, because this whole segment is E, so they're just calling it that. Okay, because it was Earth, circumference, surface,
Okay.
or Everest circumference, okay? So I have this. So, what is 6,408 squared?
Oh my gosh. A big number.
I'm not saying a number aloud.
Just read it by number.
Did you get 41,062,464?
Yep.
And then you're gonna take 6,400 and you're going to square it. So that you get 40,960,000.
This
That's
is
too
complete.
much.
This literally makes complete sense because we're figuring out the Earth.
Right.
We can just call it out to the twins.
So now you're going to subtract 40,960,000 from 41,062,464, right? So we're gonna get a more reasonable number here in a second.
It's too much.
41,062,464 minus 4096,000.
One.
102,464, right? And then what do I have to do to that? How about take the square root of it? So take the square root of that, 102,464, and you get approximately like 320. It's like 320.09, right? So I'm just gonna round to a whole number of 320. And what unit measure is that in?
Meters.
Kilometer, yeah.
Kilometers.
You're not killing our meters, Kayla.
Okay, okay. Well, one was in, she is correct, because one was in kilometers and one was in
No,
meters, so you just had to know which one you were working with at that point. Right. So this stuff is not hard with the tangent stuff because you can set them equal to things
It's
and solve.
literally just the Pythagorean theorem.
It literally is. Now, let's take a look at another.
Something harder for me.
Oh, yes, construction.
Ow, I'm hurting. I know.
Okay? I know they're your favorite things. And then I'm gonna actually throw in an extra little problem here in a second for us to look at. Because I forgot to put it in. Constructions. constructions, okay? When you are constructing a triangle and inscribing a circle in it, when you're putting a circle into a triangle, because you need to solve things.
Why?
Okay. The first thing you have to do is you have to bisect an angle. Okay, you're gonna bisect one angle. Bisect means you do what to it? Cut it in half. So I'm going to take a ruler and I'm going to set it and bisect an angle. I'm gonna make a little arc with my compass, right? And bisect the angle. Okay? Once you do that and you draw a line through that bisect, you go to another angle. Okay, doesn't matter which one, you go to another angle. And you bisect that angle. So now I have two lines that have bisected angles, okay? And they have crossed. You see how they cross here,
Yes.
okay? They intersect at the circle's center. Okay? From there, it's very easy. You construct a perpendicular line from the center to the triangle's side. So you're creating from here, do you see this line right here? It's perpendicular to the side. So they took this and then they made a perpendicular bisector of the, or made it perpendicular, okay? So this is blown up a little. Oh no, this is when I want to put a triangle in a circle. So to make it perpendicular. And then you just take your compass and you put it on the middle point. And I go whoop, with my compass and make the circle. Okay, it's not hard. When you are putting a triangle inside of a circle, okay, you have to construct a perpendicular bisector. So you look at the circle that you have, okay, or you look at the triangles and you create the perpendicular bisectors from the sides. What's that called when you create perpendicular bisectors? What point does it make in a triangle?
Right.
In centers, not.
Wait, what?
Let me think about this. Angle bisectors are in centers.
Yeah.
Orthocenters go with altitudes. Perpendicular bisectors go with, it's either a centroid or a what? Is a median a centroid or is a perpendicular bisector? And then there's a circumcenter, right? So is perpendicular circumcenter or centroid? Circumcenter. It's the first one. It's the first one we learned. It's circumcenter. Okay. So what you're doing is, if you are putting a circle around a triangle, you are finding the circumcenter. Okay. Once you find the circumcenter, you can draw your circle because that's the center of your circle. The circumcenter is the center of your circle and the center of your triangle. Okay? So you have to find perpendicular bisectors to create your circumcenter. Now, we're going to add one more little thing to this and then we'll be done. Let's say I have a circle. You're going to pretend that everything I draw is perfect today, okay?
No, thank you.
So we're not. So we're not.
Here's my circle. It's easier to make it that big. This is the center of my circle, point C, okay? Off of the center, off of my circle, I have lines that look like this. Okay, what type of lines are those? If they touch the circle at one point? Tangent. Okay, and we're gonna name this point here T, we're gonna name this A, we're gonna name this N, okay? And we're gonna say that segment TA is x squared plus x plus 4. And we're gonna say that segment TN is 20 plus x. Okay? And then we're gonna say, what is the length of either of the tangents? How can I solve that? What is the length of either of the tangents?
Oh, I love that for you. Could you set them equal to each other since it's an isosceles triangle?
Beautiful, yes.
But I said it, so shut up.
What is the length of the tangent? So you're gonna set them equal to each other because I know that if two lines are tangent to the same circle, they are equal, okay? If they meet at an end point and they're tangent to the same circle, they're equal. So I know that this segment and this segment are equal. So I'm gonna say x squared plus x plus 4 equals 20 plus x. What do I do from there?
Combine like terms.
Get everything on one side, right?
Mhm.
Okay, so I'm gonna subtract x, yes? So that I have x squared plus 4 equals 20. Then I'm going to subtract 4 and I get x squared equals,
16.
which means what? X equals,
4.
because I don't have a negative distance. Now it said, what is the length of the tangent? And am I done?
No.
No, so what do I need to do?
You plug it in.
Okay, which equation do you want to plug it into?
The 20 plus X.
Right, because that's easy. So 20 plus 4 equals 24 units in this case, because they didn't give us a measurement. Okay, so tonight on your homework, you're gonna use the law of Pythagorean theorem, they're gonna do stuff like that. Okay, setting stuff equal to, each other if the lines meet at an endpoint and are tangent to the same circle, they are congruent, okay? Okay, Kayla, hit it. Yep.
Like, subscribe, comment, tweet me at David Dobrik. Anything else to add, Bryson?
Bro, if you're watching this, you're childish.